In an earlier video that I can link here at the end, I talked about factoring. And factoring in algebra can mean a lot of different things. And the type of factoring that I talked about previously was a general type where we have a parabola. We've got, an x squared term, we've got an x term, and we've got a term with no x. And this is a trinomial because it's got three pieces. It's in standard form, x squared, x to the first, x to the 0, or no x. And we would find our factor by figuring out two numbers that multiply to 10, and then we would pick the pair that also adds up to our middle term, our 7. And this would factor to be two binomials. Got my x there. But I want to talk about a different type of factoring. I want to talk about factoring when every term has something in common. For example, if I had something like this. So first of all, just note that there aren't three terms in this example. And also, this had an x squared, this had an x, and this had nothing. This had no x. But down here, every term has an x. There isn't that last term. So when I have a situation like this, where it isn't a trinomial, or it's just, has something in common, every term has something in common, here are the two things I look for to factor. One, of variables that they all have in common. In this case, they each have an x to the first. Now, of course, the first term has an x squared, and the second term has an x to the first. So they at least both have an x to the first. So let's start with that. I could take an x and divide that out, or factor that out, of each of those terms. Now, I always like to just check here and say, okay, if I distributed x times 3x is 3x squared, x times 12 is 12x. So I haven't changed anything. I haven't changed the expression. I've just factored it. I made it look a little different. The next thing I look for is, do they have a number or a factor in common? Like a number I could divide out. And in this case, both 3, the first one, is divisible by 3, but 12 is also divisible by 3. So I'm going to pull a 3 out. I already have an x. So 3 divided by 3 is just 1x, and 12 divided by 3 is 4. And again, I like to just check and say if I distributed 3x times 1x is 3x squared, 3x times 4 is 12x, and I have not changed the value. This is my factored form. And as I said in the previous video on factoring, the reason we factor is oftentimes to find solutions, to find zeros, to find out parts of the graph that touch the x-axis. And we'll get more into that in later videos. But for now, just recognize that both types of forms of the equation, the kind of all distributed out one here, this has value, but this one also then has a different type of value to us. Let's do a couple more. All right, here I've got a couple more examples. And again, on the first one, let's start with the variable that appears in every term. And by the way, if a variable doesn't appear in every term, you maybe still could pull a number out. But oftentimes when a variable doesn't appear, it maybe means that first type of factoring where we have the two parentheses would work. In this case, I do see an x and everything. At least an x to the first would be able to be pulled out. So I'm going to do that. Let's write x right here, which leaves me with 15x squared plus 6x plus 9. And after that, then I look for a number. Is there a number or factor I could divide out of every term? And each of these numbers, 15, 6, and 9, are divisible by 3. That'll be the biggest number that would go into all of them. So I'm going to pull a 3 out. So 15 divided by 3, 6 divided by 3, and 9 divided by 3. And there we are. Let's do the next one. So 14x cubed minus 7x squared. Well, in this case, of course, they have an x, but actually, each one of them has an x squared. So let me write x squared. That'll leave me with 14x minus 7. Right? X squared times 14x is 14x cubed. And then I look to the numbers. Of course, 14 and 7 are both divisible by 7. So I'm going to pull a 7 out and put it with the x squared. 2x minus 1. 7x squared times 2x is 14x cubed. 7x squared times 1 is minus 7x squared. Let's do a couple more that are a little bit bigger. All right, so now I've actually got a little bit bigger equations. I've got some different variables. But let's check the variables first. Okay. Now you see that there's an a squared and an a. So they both at least have an a that I could factor out. I'm going to write that down real quick that I can pull an a out. They also both have a b. Just a b to the first. I'm going to pull that out. So when I pull an a and a b out, I've got 10a plus 15. So ab times 10a would be 10a squared and b, and then ab times 15 would be 15ab. Of course, next up, I look for those numbers or factors that are divisible. Well, 10 and 15 are both divisible by 5. So let's pull a 5 out. 10 divided by 5 is 2. 15 divided by 5 is 3. All right, next, let's look at this one. It's got a lot of stuff going on here. Let's start. Every term has an a. That first term has an a squared, but every term has at least an a. So let me pull an a out. Next up, every term has at least a b. This one's got a b squared, but at least just a b can be pulled out of everything. So let's start with that. 15 is going to stay here. Now I pull out one a, but this was a squared, so there's still going to be an a left, but the b will be divided out. 25. Now the a was factored out, but the b, I still will have one b left. And then on this last term, both the a and the b were factored out. Yeah, and as these get bigger, you might want to check, just every step. ab times 15a, the 15 would be there, and a times a is a squared, b, yep. ab times 25b, be 25a, and then b times b, it's the b squared, and then, of course, 35 times ab. And now we look for the numbers. Well, 15, 25, and 35 are all divisible by 5. 15 divided by 5, 25 divided by 5, and 35 divided by 5. And there is my factored form. If this video helped you, please like and subscribe for more math help.